Systematic focal point bringing damage to your burrow. Need some brothers from the east with them beats that be thorough. Got the solar gravitation, so I'm bound to pull it. I gets down like brothers are found, ducked in from...
We know that a current running through a conductor produces a magnetic field, and also if another conductor is placed into the magnetic field, there will be some force acting on it because there are charges moving inside that conductor. In this video we'll study the nature and magnitude of this force interaction. Let's evaluate the force acting on conductor 2, so we call it F2. As we know from before, it's the current in I2 times the vector L crossed by the magnetic field vector, which in this case is the field produced by the current 1. And this L vector is along this second conductor, so we should call this L2, and its direction is in the direction of the current 2. So, for example, at this point here, the magnetic field is into the screen, so in this manner B1, and as you can see, the angle between these two vectors, because they are perpendicular, is 90. So if we just evaluate the magnitude of the force, we get I times L2 times B1, and there would be the angle between the two, which is sin 90, and this of course equals 1, so we only have I times L2, so this is I2 times B1. There is some distance between the two, let's call it R, and at this distance the strength of the magnetic field due to current 1 is mu0 divided by 2 pi I1 and the distance R. So if we plug this one in here, we get mu0 divided by 2 pi R times I1 times I2 and L2. So this expression will give the force acting on conductor 2, which is produced by the field of conductor 1. So you have these both currents occurring in this expression I1 and I2. Next, let's determine the direction of this force. So according to the right hand rule, when we need to calculate L2 cross B1, we point our fingers of the right hand towards the direction of L2, which is in the direction of the current, and then we curl towards B1, and in that case our thumb ends up pointing to the left towards the other conductor, so F2 would be in this direction. And if you repeat this same process for the force acting on B1 on F1 due to the magnetic field B2, we would get the result exactly the same expression, but the force acting on I1 would be towards the I2. So we get the result that if these two currents are going the same direction, the two conductors will attract each other. And if they're going in opposite directions, then the converse is true. These forces are away from these conductors, which means if we have like this I1 and we would have I2 going in this direction, that would reverse the force F2 and also the force F1. So currents in different directions make the conductors repel each other, whereas the currents in the same direction makes them attract each other. This kind of behavior is comforting from the point of view of Newton's third law, which states that every force is counteracted by equal and opposite force. So when we first evaluated F2, we knew that there has to be a force F1 that is equal in magnitude but opposite in direction. And that is indeed the case. And also in here, when F2 is to the right, the F1 was found to be to the left, which is consistent with what Newton's third law says.
Nowadays ain't odd. Investing in fantasies and not God. Welcome to reality. See, times is hard. People try to snatch the credit but can't claim the card. Showing out in videos saying they co-starred. See, shit like that'll make